Hello, everybody that's watching in the future or um, elsewhere. This is Coder Chapter 7, Sharing Role Behavior with Modules. I'm Mary-Katherine McKenzie. I've been programming Ruby for just a little while. I'm still a newbie, but my first interaction was earlier this year, so getting into it. Clayton, do you want to introduce yourself?
I'm Clayton Flesher. I've been doing Ruby for a little over a year. That's about it.
Cool. Jay, do you want to introduce yourself?
Yeah, sure. Same story as you guys. I've been learning Ruby since the beginning of this year, and I just started reading this book, and the first couple chapters were pretty good. I haven't had a chance to read this chapter yet, like I was saying, but a lot of good concepts in it, and I randomly saw someone's tweet. Clayton, it might have been your tweet I saw randomly today on Twitter, and that's how I found it, so I ended up
Good.
Cool.
here. So, yeah.
Good.
Nice. Yeah, so the cool thing about this book is that you don't necessarily have to have programmed a whole lot before, or even read all of it, I think, because it does have good concepts and they build on each other, but they're also, I think the chapters work well as kind of standalone chapters too, so yeah. So, okay, I'm going to start the PowerPoint and share my screen.
Be sure and tag yourself on your view so that the video only follows you.
Oh, that's right. So yeah, I haven't actually looked at the last ones. Did it mess up last time?
I don't remember.
Okay, because I think last time I tried doing that, but I didn't actually look at the results.
I think it worked right, if I remember correctly.
Okay, so let's see. I will do screen share. Screen share. Ooh, okay. Can you see my screen?
Oh yes, the infinite regress.
Always fun. Okay. So, Chapter 7 is about sharing role behavior with modules. So, in the last chapter, we talked about acquired behavior through inheritance. And this is kind of similar to that, but there's a little bit different, some different stuff that goes with it. And we'll get into how they're different. So kind of the summary of this chapter was that Ruby modules are used between objects that share a common role and need to share behavior. So a chunk of code that you'd want a lot of objects to share but don't want to replicate in each object. And that's pretty high level. So with classical inheritance, we figured out how to get the different types of the bicycles under the bicycle class. And I don't, Jay, have you been introduced to the whole bike metaphor thing in Chapter 3?
Oh, yeah, with the gears and stuff, yeah.
Yeah, so she kind of goes through and starts this bicycle shop, and they have different kinds of bikes, different kinds of trails. People have to rent bikes, and bikes have to have all these different requirements. So the different kinds of bikes that she was talking about were mountain bikes, road bikes, and recumbent bikes were kind of added in at the very last minute. But now there comes a question like, well, what if you want a recumbent mountain bike? And I think the recumbent bikes are those ones that are you sit down, I think.
Yeah, sounds right.
Yeah.
Okay. I was wondering what those were.
Yeah,
these are the bikes you lean back in.
Right, yeah. So I guess you can have a recumbent mountain bike or a recumbent road bike. So then it kind of gets in this murky water, like, well, if it can be technically under two classes, like where do you put it? Or like how do you sort that out? So that's what we kind of get into with this chapter.
Classical inheritance is notoriously bad at that.
Wait, do what?
Classical inheritance, which is what we went over in the last chapter, is notoriously bad at dealing with that.
Right. Yeah, so classical inheritance is pretty, you can only inherit from one thing, so you can't have um, multiple objects that you're inheriting from. Um, but with modules, you can have multiple modules, but we'll get into that. So the next section talks about understanding what roles are. And roles she kind of defines as like a common behavior. When formally unrelated objects begin to play a common role, they enter into a relationship with the objects for whom they play the role. So kind of sets us up there for finding roles. So in this, she talks about the preparer duck type in chapter 5, and that was let's see.
So, like, any kind of class that can prepare a trip is a preparer and inherits from preparer. And any kind of class that can be prepared is a preparable and it inherits from preparable.
Right. So, like, what was an example of a preparer?
There was like a, I think it was something like you could have like a mountain hike or like, I can think of examples, like different kinds of trips.
Okay.
I think that was an example she gave.
Yeah, so here she says the preparable role is not inherently obvious because the trip is its only player, but it's important to recognize that it exists. So in this case, she's saying that the trip class basically just told everybody to get their stuff in order, get the bike, get the mechanic.
The trip's preparable. The preparer is the class that is preparing the trip.
Right.
Yeah. So that could be like all kinds of stuff.
Right. So she's saying that these typically come in pairs, a preparer and a preparable, but we only talked about having a preparer explicitly. So this is an interesting thing that she brings up. So modules she defines as a named group of methods that are independent of class and can be mixed into any object. So this is slightly different from, this isn't different from classical inheritance because you use the syntax include underneath the name of the object as opposed to, like in a class, as opposed to explicitly stating it on the class name. So
you can actually inherit from a class and still have modules that you include for module inheritance. You can actually do both kinds of inheritance on the same class.
Right, but you can do multiple modules and only one inheritance.
Yes, though I think it's frowned on doing multiple modules, I think.
Okay. Yeah, so she also notes that other object-oriented languages have this, but in Ruby it's called a module. So all of the methods in the module are now available to the class it was included in.
Does that include like through inheritance? So like, say we have a bicycle class and the mountain bike inherits from the bicycle class, right? If we included a module into the bicycle class, are those methods available in the mountain bike class as well?
I believe so, yes.
Okay, that's how a module works. Any method you define on a module, if you include that module, that class then has access to all those methods.
Yeah, and so this slide actually says it. So it has the total set of messages to which an object can respond includes all of these, and you see the last one says those implemented in all modules added to any object above it in the hierarchy.
Okay.
So
and I think that's actually in the order that takes precedent. So the actual methods explicitly defined in the class take priority, and then those implemented above it in the hierarchy, that may not be true. Actually, that may not be right. I'm not sure what the order of priority is for modules. That's where things get hinky.
What's like a best practice? Is it putting all the modules in like the highest class?
No, No, I don't think so.
Whatever it's most relevant to.
I think it's wherever it makes sense, because some of the modules examples she gives, like, I don't know. Like I think the best practice is that you put it on the class where it makes the most sense to put it.
Yeah.
Because
Yeah.
if you put it at the highest level, then you have something that's like 3 or 4 levels below, you're going to be getting behavior that you might not expect.
That's true.
And
Yeah, and I think
it's going to show up out of nowhere.
right. Yeah, and she talks about kind of how you want the class that you include the module in, you want it to use every method in that module. Like you don't want to have any extraneous. So, I mean, I guess that wouldn't really matter if you had it further up, but yeah, it would just be harder to find. And I think this is kind of the point that she's making here is like there's a lot of different places where you have to look for methods now that respond to this object, because
Right.
not only do you have to look in the hierarchy, you have to look in every module included on every branch of the hierarchy, and it can like really get into the weeds there with it's a lot of potential responses. So here she talks about organizing responsibilities, and this is just kind of setting up. So the problem, we're scheduling a trip, and the trips have to happen at a specific point in time, and they involve bikes, mechanics, and motor vehicles. You need to know if these objects are available or committed. The complications are that each object needs a specific amount of downtime between trips, and downtime varies. So now we've kind of thrown some interesting stuff into the mix. So a new schedule class now exists. Its interface includes these methods. And I believe this is schedule is kind of a duck type, right? Or it is.
Yeah, I mean, it's going to end up being one.
Right. So, so I guess everything that needs to be scheduled will have these methods in it.
It's actually not schedule itself that's going to end up being the duck type. It's going to be something like schedulable.
That's right. Yeah. So, so we've basically figured out, okay, this will tell us if it's scheduled, if it's unscheduled, but not if it's available to be scheduled. So we need to take lead time into account. And here's kind of a setup of how she does that, and she also kind of goes through the pattern of like an anti-pattern, I guess she calls it, where you go through all of the steps that you might get wrong, and then she fixes them, which is great. So for here she.
So like it says.
Yeah, I don't really understand this.
So, okay, I can tell you what the code here is
Yeah.
doing. So the bicycle is going to have a different amount of downtime between trips than a mechanic, and then like a car, for example. We're going to call vehicle car or whatever. Okay. So like one needs 1 day down, the other needs 4 days down, and the other needs 3 days down between trips. Let's say. So what it has to do is whenever it gets an object passed to it, the schedule has to say, okay, well, what kind are you? Are you a bicycle or a mechanic or a vehicle? And then it decides whether or not it's schedulable based on that. And that's not what you want to do, because then it has to check the class of every object that gets passed in, which is exactly what we want to avoid.
Mm-hmm.
We want it to ask, is it schedulable, and it tell us yes or no.
Right. Yeah, so, this should raise red flags. Schedule knows too much now. All it needs to do is send messages. So, removing unnecessary dependencies. Checking class name as a dependency and should be removed, which you just talked about. And then, yeah, okay, so here we go. Discovering the schedulable duck type. So it removes the check on the class names, which is which is helpful. So now we have this kind of unnamed class called the target, or a target. And we don't know the name. It just needs to respond to a message, and it needs to respond to lead days. So now we've discovered this schedulable duck type.
Right.
So now this still has some dependencies, even though we've abstracted out the duck type. So objects should manage themselves. They should contain their own behavior. So if as schedule, the dependency here is it asks schedule if target is schedulable instead of just asking target directly. We just need to cut out the middleman there and ask the object who we need the message from.
Which is why, so that's where our mixin is going to come in. We need anything that is going to respond to schedulable is going to get the mixin for schedulable.
So now we need to write the concrete code. So we need a schedulable method, but where should it go and what should it do?
And we got to put it somewhere.
Right.
We don't want to put it on every single kind of class that responds to it. We want to put it in one class because that way we're not repeating it over and over again.
Right. So we know that we need that somewhere else from where it is right now. So now we're onto the diagram here again, a new one, or not a new one, I guess, an edited one. So bicycles now can speak for themselves. They don't need to ask target again. When it comes to schedulability.
So you see what she's doing here. She's actually implementing it directly on the bicycle class first, and seeing bicycle is something that is schedulable, so she's implementing that method directly on the bicycle class first, just to kind of get a feel for how it's going to work.
So now we have kind of the schedule, I guess.
Right, yeah.
This
is where she breaks it out.
Right.
No, this is just on the schedule class. Yeah, this isn't on bicycle.
Yeah, so this is just the schedule class. And so this is where she's pulled it out of all of the individual things that are schedulable.
So what you're going to do is where it says schedulable, it's going to pass in. That's going to actually be the bicycle or the vehicle or whatever. You're going to pass the class into the first argument, and then you're going to pass the parameters for when they want the trip to be in the second and third.
Right. Yeah. So now we've got this all set up, but she does note that it's non-production worthy, so we still have a ways to go with that. So the bicycle class now hides knowledge of schedule, which is good because it reduces dependencies. It doesn't need to know all the information about schedule, it's just a message, or send a message. So let's see, bicycle class now hides the knowledge of schedule. So now, yeah, we've run it and it's worked. Down there, you can see it 36, 37, 38. It kind of has a, we've run the code and it works for that. So I don't know, Clayton, do you want to talk about this a little bit?
Yeah. So what she's doing, she's implementing all of the stuff that she's ultimately going to break out into the module on the bicycle class first, just to get a feel for how it's going to, you want to implement it on a concrete class that you've got first, get it working there, and then she's going to split it out into something more abstract and pass it back into the bicycle. But these are all the methods that she wants to get that are associated with schedules. So, like, ignore size, chain, and tire size. That's all code that we dealt with in another chapter. But what we want to know right now is whether or not this bicycle can be used on some trip. And so what we're going to pass in is we're either going to pass in the schedule or we're going to create a new one in the initialize. And then we're going to ask this bicycle object if it's schedulable. And what we're going to give it a start date and an end date to see if it's schedulable in this window of time. And then there's another method to ask if it's currently scheduled in this window of time. And then the lead days is just how many days between trips a bicycle needs to be down. And then we look down here at the bottom, starting equals date dot parse, and that just creates a date that can be used and dealt with by it, and an ending date. And then b equals bicycle.new, that creates a new bicycle, and then it asks if bicycle is schedulable by passing in the starting and ending dates, and it says this bicycle is not scheduled between this time, and returns true.
Yeah, cool. Okay. So yeah, that makes sense. So now we can. Oh shoot. Well, didn't edit that one. So essentially, this should say. So now we're basically doing what we said before, and then pulling out that code that we know works, but we want to be able to apply elsewhere. Okay. Quick fix. So it's time to rearrange the code so that it can be shared among objects of different classes. Methods have been abstracted out of the concrete class bicycle, all of chapter 6. So now we have a schedulable class that contains those methods we know work.
She took all of the methods that were in that bicycle class that she just added to it, stripped it out, and put it in something else. They're the exact same. It does all the exact same stuff.
Right.
It just, and except that she has she has default lead days as 0, and she has. I don't think otherwise there's any major difference. No, otherwise the code's exactly the same.
Mm-hmm.
She just changed lead days.
Yeah, and she does note in there with the comment that includers may override. So I guess what we were talking about earlier with the kind of what overrides what. The initial class will override methods and modules that it includes.
And if you look there under the schedule method, it's at schedule or equals ::schedule.new. That has to do with the fact that it's in a module, the : part.
Yeah, so, that was kind of confusing to me. Could you elaborate?
Yeah, whenever you have a module, it's going to be, let me make sure I don't screw this up. And Jay, hop in if I say something wrong. But I think when you actually call an instance of a class that's in a module, you call the module name, and then the class name .new. So it'd be like, I think if you actually have a new instance of schedule, let's say that our schedule is schedulable module with a schedule.new class, then it would be schedulable : schedule.new. Or in this case, yeah. I think that's right, but I'm not super certain, and I'm sure we will hear from those who are all about it.
Yeah.
I've only used modules a couple times.
Yeah, it seems a little intimidating.
You'll notice a lot of times when you use gems, it's the same way. You'll have like some name, like the name of the gem : some class dot new or some class dot some other method, and that just it namespaces that class for it prevents you from calling that a different version of that class that is not associated with that module. It's a namespacing thing.
Oh, okay.
It prevents you from calling a version of schedule that is not the right kind of schedule. But I don't know in this case if that's what it's doing, but I know that's one way that modules get used. Because you can have let's say you had a bicycle class for schedule for this that inherited from one thing, and then you had a whole nother module that also had bicycles in it. You would want to make sure you were calling the right kind of bicycle.
Mm-hmm.
Like not just like mountain bike, but actual like bicycle class. So you can have like this gym bicycle class, and then this other namespace bicycle class.
Okay, I think I get what you're saying.
Yeah.
I just because I haven't used it, I don't.
You'll see it when you start using gems a lot more.
Right.
Like stuff.
Cool. Yeah, well, I'll keep an eye out.
Anywhere we see the : that's something to do with modules.
Okay, because I've definitely seen them before, just like reading through stuff.
Yeah. Mm-hmm.
But yeah, that makes sense now that it's module associated. So I think, let's see, where are we here? Okay, we're on like page 51. So,
sorry, I derailed.
Oh no. That was good. So now we've this is kind of our bicycle code now that we've abstracted out everything into that other module.
Okay, so do you see what she's doing here? She includes the schedulable, and then she goes ahead and defines lead dates. You see why she does that?
Yeah, because
yeah, the schedulable has a default lead days. So that if, for example, you had some object that was schedulable that didn't have any lead days, you wouldn't need to define lead days in that class. But because bicycles lead days are not 0, it goes ahead and defines them inside the class, and that overrides lead days reference in the module. It redefines lead days to what within the context of bicycle to 1 instead of 0.
Right. Yeah. So each class that's schedulable. So like mechanic and vehicle would also have lead days that are different than
if they're not 0.
Right. But if you forgot, see, this is what I know. She says kind of later you shouldn't write to throw an error, but if later on down the road somebody forgets to add lead days in there and they just get incorrect data, right?
That's why you only put methods in a module that are going to be needed in every. That's why it's really important to get the right abstraction.
Right.
So, because you always want to make sure that all of the methods in that module are going to be implemented in every example where you include it.
Mm-hmm.
And it's always going to make sense. So it's really important to do that, to get the right abstraction.
Right. Yeah. So I guess in that case you would, I guess if you were writing a new class that were schedulable, you would refer back to the schedulable module. I feel like this is a lot of, like, once you get into bigger applications, I feel like there's just a lot of hunting down things that you need to do.
Yes, but if you say include right there below the class definition, that
Uh-huh.
lets somebody know, oh, I need to go look in there and make sure that this matches up with that. That's like
Right.
why it's the first thing in the class, and it's super noticeable that it's being included.
Right.
And so whenever you include it, it's your responsibility when you include a module to make sure that all of the methods for that module make sense for your class. Otherwise, you don't need to include that module. You need to do something different.
Right. So I guess yeah. Okay, yeah, that makes sense. But I mean, like, what if you just like genuinely forgot or like didn't override it?
Well,
You
you're
just get
going to
bad
create
data.
you'll have problems in your code. I think she actually talks about that at one point. If you
Yeah.
have lead days in there and it doesn't make sense for lead days to exist in that class, then that class is going to respond to lead days, and it may respond
Mhm.
in lead days to a way that makes sense at that moment, but then 5 or 6 steps down the way, buried somewhere deep that's hard to find, something's going to blow up.
Right.
So
Yeah,
that's
that's
why it's so important not to do that.
right. Because I think she mentioned somewhere like not um, setting that default as a number and not as throwing an error. You know, saying like you didn't
Yeah,
set lead day.
right.
But then I feel like that does leave it open to
I don't
um,
remember what she said about that.
right. Yeah, I think it's in there. It's in this chapter, and we'll get to it. But yeah, that's something that I kind of was scratching my head about. But I guess it's just something that comes with experience too.
Does
So
she recommend against or in favor of throwing an error?
I think she recommends against it.
So I would think that might actually be a good idea. Like if well, maybe, I don't know.
Yeah, she kind of maybe.
Well, is it throwing an error inside the default? Is that what she talks about?
I think so.
Because you wouldn't want to do that because you want the whole point of getting a module is that you're inheriting default behavior.
Right. Right. But what if? Yeah. Okay. Yeah, I see what you mean. Yeah. Um.
Data and default.
Um. Yeah. I think
Otherwise, like you don't get any positives out of it.
right. Yeah. Okay, that makes sense. I think she does address it later, but we'll put a pin in it because that did
I
confuse
think
me.
that may be. She may have talked about that with like Java or something. I want to say that's something Java does. That like it requires you to implement every single method in the class that inherits,
Uh-huh.
and you don't actually inherit the behavior from the other class. But that may not be true either. I don't know. I don't know Java well enough yet.
Um.
I don't know. If you run across it, point it out, and we'll look at what
Yeah.
she says. And I'll
Yeah.
try to read it again before next week and come back with it.
Yeah. We'll see. We'll circle back with that. Um. So now we are moving on to the schedulable duck type here in figure 7.4. So on page 152, my annotation is covered up there. So let's see. These like diagrams are still like they're not like instantly understandable for me. I still have to like kind of work through them.
Yeah.
But I feel like I'm getting there.
So I think it's just um, I think she's just talking about the same thing that she implemented in the module before. I think she's just showing it in this one.
Right.
And she's showing the interaction between how a schedulable class or something that is schedulable, like a bicycle, is going to interact with um, the schedule object. The schedulable is a mix-in. Schedule itself is an actual object or an actual class.
Right, right. Okay. So, okay, that makes sense. So, like, a schedulable could be any class in which that is mixed in.
Right, and then the schedule is not going to. The schedule is a whole separate class that tries to organize schedulable stuff into a schedule.
Right. Okay.
Makes sense?
Yeah. So I think the next slide is when she kind of takes that out and puts it into code here. So yeah, so here she has vehicle and mechanic as being also schedulable.
Mm-hmm.
So she's saying this is kind of where she kind of has the big like, hey, this looks like inheritance, but it's not. And this is also kind of when she talks about the is a versus behaves like a.
Right. So the last chapter was an is-a.
Okay.
Yeah. So when you're actually inheriting, when it's actual inheritance from class to class, the class below is a version of the class above.
Okay. So like
In
mountain
this
bike
case.
and bicycle.
Right. A mountain bike is a bicycle.
Right.
So in this case, a vehicle behaves like a schedulable, but it
Okay.
isn't an actual. It isn't inheriting. It isn't getting passed. It isn't getting directly passed down. I'm not sure what the importance of the distinction is, but I see that I understand what distinction she's making.
Mm-hmm. Yeah. She talks the next sentence after the is a versus behaves like a is each choice has distinct consequences. So she does
Yeah.
talk about differences. So
What
she
are the
kind of talks,
consequences?
yeah.
Yeah, here we go.
Yeah. So it's page 154 is where we are now. If you're following along. So she says here, understanding similarities between classical inheritance and module inclusion is easier if you understand how object-oriented languages in general, and Ruby in particular, find the method implementation that matches a message sent. So this is what we were talking about kind of at the very beginning, like where does it go up the chain? And then she has some diagrams here that explain how that happens. So this is just, I believe this is just classical inheritance, right?
It is, yeah.
Yeah.
So at the bottom you have just an instance of a mountain bike. That's why it's all in lowercase, because it's just a single instance of a mountain bike. And that instance of a mountain bike is an instance of the class mountain bike, which is an instance of the superclass bicycle, which is an instance of the superclass object.
Right. So, and then in each one, we're looking for the spares method. So we're
Right.
going up the chain and looking to see where it is.
Yeah.
So, and she does mention that's a gross oversimplification.
But it's basically correct for the purposes of what we're doing.
Right. So now here we go with a more accurate explanation. But classes now includes modules. So we'll look in modules before moving to a superclass. Okay, so this is should be answering the question.
Right.
So it'll look, I guess. Do you think would it be accurate to think of modules like peers as opposed to parents?
Kind of, maybe. I mean, I don't know that may actually make things more complicated.
Okay.
I'm not sure what the right analogy is, but the example she gives here is pretty good. It says that you get past the method schedulable to an instance of a mountain bike, which is an instance of the class mountain bike, which is an instance of the superclass bicycle, which has a module schedulable, and the superclass of bicycle is object. But schedule well, I think the superclass of schedule. I don't know that schedulable has a superclass because it's just a module. So it doesn't actually have a superclass. The superclass of bicycle is still object. It just has included the module schedulable between bicycle and object. So bicycle still takes precedence. So that anything that's defined inside a bicycle takes precedent over schedulable.
Right.
But anything inside of schedulable is going to take precedent over object in the lookup.
Right. So, but technically isn't, I mean, wouldn't the superclass of module be object eventually?
Modules don't have, modules are not classes technically, I don't think.
But they don't have, so they don't have like, they're not objects technically, so.
I'm not sure how that works.
Right.
But I don't think schedulable, I don't think object is a superclass of schedulable. I still think it's still just a superclass of bicycle.
Okay,
like
yeah.
modules are a different thing. Modules are a different kind of thing.
All right. Okay.
Than a regular class. Like you can't have an instance. You cannot have an instance of schedulable.
Right.
Schedulable only exists within the context of something that it's been included in. Does that make sense?
Mm-hmm.
Yeah. You can have an instance of a class. You can't have an instance of schedulable. So schedulable is not a class. It's a module. It's a different kind of thing.
Okay. So Jay, I think you had that question earlier. Did that make sense?
Mm-hmm. Yeah.
Okay. Cool. I knew we got to it at some point.
I think that's right. I'm pretty sure that's right. We'll hear about it if it's not.
Right.
Yeah.
So let's see. 7.6. All right. Yeah. So
even more.
Oh shoot.
More accurate.
Yeah. I think I did this in a hurry last week, and then I was also like super tired, so half of these just didn't get rotated.
And the fact that you even do these is like.
Well, it helps a lot because I end up reading the chapter like 5 times. It's great.
Yeah, no, it does. It helps a ton. It also helps a lot for us to like be able to go through it page by page, especially if we don't have somebody who has it sitting in front of them.
Right. Yeah, that's kind of what I was thinking.
And the video, I mean, every time you've done this, ever since the video, people are like, you don't have these for the first few.
Right.
And because this is super helpful.
I know. I need to go back through and like, I mean, it won't have them obviously but I think the first couple.
The first couple of chapters you can get by without it anyway.
Yeah. Yeah. And plus we were still trying to kind of figure out what our deal was. But yeah, I like doing the PowerPoints. But anyway, so now we've got kind of this more drilled down version of the hierarchy or the method lookup. So modules also have hierarchy. It'll look in reverse listed order. So
So 4, 3, 2. What 4 gets looked up before 3, before 2, and before 1.
Right.
Yeah.
So it just kind of goes like straight up.
Well, it sort of goes straight up. So it goes, any message gets passed to the mountain bike, that particular mountain bike. And before it actually looks in mountain bike, it looks in singleton, which I don't know a lot about because I don't ever use the thing that exists anymore. And then it have modules, I guess, on singleton. Why you would, I don't know. And then mountain bike, and then modules on mountain bike, and then bicycle, and then modules on bicycle, and then object.
Mm-hmm. Yeah, so I guess if you only have like, I guess this could turn into a whole like tree map type thing.
Oh yeah, well yeah, definitely a tree, or definitely like a big, yeah, like that's a whole lot of lookups.
Right.
And you can have modules anywhere along there. Like
right.
I've never heard of putting modules on the singleton class, but I bet if you're using the singleton class, it probably is something you might do. I don't ever use a singleton class. I'm not sure what it's good for.
Right.
So I don't know if it's something you would put modules in or not. But yeah, that's a lot of lookups.
Yeah. Because, I mean, you could potentially have
Just one. Yeah.
so many modules.
Yeah, there's a reason why Ruby's slow.
Right.
Relative to a lot of other languages.
Right. And I wonder if it would help, like, do people, when you get into stuff that's complicated like this, would it be helpful to draw it out? Is that something people do, or is it just kind of like you just do it so ad hoc that it's not?
I don't know. I mean, I'm sure some of this stuff gets whiteboarded out at certain places. I think a lot of the times it's pretty fly by the seat of your pants.
Yeah. Because I know, like theoretically, I'm like, oh my gosh, it would make so much more sense to just draw it out. But, like, I am very bad at planning things.
Well, and the problem is that until you start defining methods and messing around with it, you're like, oh, wait, that method doesn't make sense with that name and
Right.
and all that kind of stuff. Yeah, and then that behavior probably needs to be moved over here, and never. Yeah, I think whiteboarding is a version of waterfall. It's just a slightly less awful version of waterfall, but
Right. Because you don't really know until you get in there.
I'm sure there's perfectly acceptable cases for whiteboarding, but I haven't found them yet.
Or there's some method that, method to the madness that makes sense that we're just not aware of.
Yeah.
So, okay. So now, speaking of method to the madness, next we've got inheriting role behavior. So this is kind of talks about you can write code that's impossible to understand, debug, or extend. Because, like we just said, this could get really ridiculous very quickly.
Right.
So she talks about you have to write properly inheritable code, and that's.
Think about it. What if you're including 4 modules at every level, and then you make a method call, like you can't see what's being called on what.
Right.
Like, it's just not possible.
Right. Yeah, that's. It kind of. We talked about, like, in some of the earlier chapters how Sandy had said, try not to do more than, like, what was it, 5 methods per class. But I mean, I don't think that is taking into account, like, modules and inheritance, right? Or else that's.
Right. Yeah, that's gonna get. Yeah. I don't know. I haven't gotten to where I've used a lot of modules yet. I haven't run into a lot of super great use cases for them. My code hasn't gotten complicated enough. But I can imagine it gets really, like, messy really quickly if you aren't super careful.
Right. Yeah. Yeah. I mean, maybe it would make more sense to draw it out as you're doing it instead of planning beforehand or, like, writing it out.
I would think until it's just impossible, it's better to write procedural code than to try to throw a bunch of modules in that, for example, have the wrong abstraction. Because when you do the wrong abstraction, you're going to end up having to rewrite, like, an entire tree of classes. If you have to make the wrong if you make the wrong change at the beginning.
Right. Oof.
Yeah.
So she says here, usefulness and maintainability is in direct proportion to the quality of the code, which is also kind of intimidating.
That's what I just said.
Yeah.
Just like, I can't. If you're not writing quality code and you're not, like, experienced enough to to write modules that aren't going to break your entire system, like I would just wait and write procedural until it, like she even talks about writing procedural code until it becomes obvious that the duck becomes just basically like hitting you over the head.
Yeah, she says, reiterates a lot that like don't make a decision until you absolutely have to.
Right.
So I think that is a big part of learning how to code. But then, it's also kind of slapping us in the face with this like big grand statement, like your code's going to be terrible for a while, but like that's just the way it is, I guess.
You have to write bad code before you can write good code.
Right.
I guess.
Right.
The trick is writing less bad code.
Right. Which hopefully we're learning how to
quantity, in both less bad in both quantity and quality.
Right. Less code, less bad.
Yeah. Yeah. Exactly.
That's a good goal to shoot for.
Yeah.
All right. So here she kind of talks about like going through the anti-patterns, like writing it poorly, I guess, and then figuring out stuff from there. This is kind of like a way to think about moving through code. I guess this would be like a refactoring.
Mm-hmm.
So speaking of refactoring and like this whole thing, do you think it's better to, like, when you start typing like a variable name style or type, do you think at that point you should stop yourself and try to implement inheritance, or write out the whole thing and then go back?
I would write out at least so it's fine to write the first version of the class, and then when you get to like 2 or 3 and they're all clearly of the same like class of type or class of style, then maybe it's time to go ahead and break it out. But it's fine to do 2 or 3, because ideally we're not writing giant classes anyway. We're writing fairly small classes, and 2 or 3 fairly small classes that aren't broken out into inheritance isn't going to make or break us, especially in the long run, where when you want to get more than one instance of anyway, because you want to see where the ducks are.
Right.
What methods need to be broken out and what methods are going to be unique to that particular class.
Right. So I guess she does go through that with the bicycle classes, where she's like, now we're recognizing a pattern here, but just so you know, we're not going to do anything with it yet because we're not 100% sure. So
right.
Yeah, I guess that makes sense.
Let's find the commonality before we try to. Like I would definitely not stop.
Right.
The first time I wrote style or type, I would definitely like put that in my little notes of like, okay, this is something I need to watch for. Then the next time I do it, oh, that's the second one. Let's see what's common between them and keep track of that. And then by the time we get around to the third or fourth one, all right, it's time to do something about this.
Right. Okay, yeah, that does make sense. And I guess that's kind of how she works here. Yeah, so here's what we've said this a couple of times. All of the code in an abstract superclass should apply to every class that inherits it. And so that applies both to modules and classical inheritance, correct? Yes.
Especially, it has to classical inheritance, but yes, it has to in both cases, because they both get all the methods. So if they get all the methods, you have to expect that class to intelligently respond to that method, because it's going to get that method.
Right. Yeah. So yeah, we've talked about that, but there it is in quotes in Sandy's words on page 159. So then she kind of talks about honoring the contract, or yeah. So that title should say contract, not content. So subclasses agree to a contract. They promise to be substitutable for their superclasses. They must take the same kinds of inputs and get the same types of outputs. But yeah, okay. So, and that kind of goes along with what we said before, because they will share all the same methods except for the subclass will have a couple extra ones, I guess.
The
That's specific to
subclasses
that.
the subclasses may have additional methods, or they may rewrite some of the superclass methods, or they may they may call super and take stuff from the superclass methods. There's all different kinds of ways they can be implemented, but they have to intelligently respond to that method and return the expected kind of thing.
Right.
So if you're expecting it to return a number, it needs to return a number every time. If you're expecting it to return a string, it needs to return a string that makes sense every time.
Right. Okay.
If you're expecting it to return an instance of another class, it needs to return an instance of a class that will respond to the kinds of things that a returned instance of that class should respond to.
Okay. Yeah, that definitely makes sense. So I think trying to see kind of outputs. So yeah, she talks about how subclasses that fail to honor their contracts are difficult to use. They can't be freely substituted. It makes the whole code look shady. The whole block looks shady at that point. So then she talks about the Liskov substitution principle.
Yeah, that was new to me.
Yeah. So basically it translates to, in order for a type system to be sane, all subtypes must be substitutable for their supertype. So I guess it's what we just said, but this is kind of in math terms.
Yeah. Yeah, it's just like a formalization of it in, math, I guess.
Mm-hmm. Yeah. So, I did think that was interesting. So, and now we get into the template method pattern. I think we talked about this in the last chapter, but I'm a little fuzzy on it.
So so the schedulable module is a template. Well, okay. So the template method pattern makes more sense to me in subclass, superclass context, but I guess it works here too. So like the schedulable module is the template for all of the kinds of things that it gets included in, like bicycle and vehicle and stuff like that. It's the template.
Okay.
Yeah.
So if you wanted to create another one that included that
it has to have all the same kinds of stuff. Yeah.
Okay. So that's just kind of like formalizing what we were talking about earlier, saying if you left out like lead days, you would want to like refer back to the module before you, I don't know.
Yeah, I think this is just giving you a term for what we've been learning about in the last 2 chapters. Like the template method pattern is just, so when you hear people talking about the template method pattern, the stuff that we've been covering in the last 2 chapters is what people are talking about. Like you have a template, you have an abstract template, and then you have either subclasses or things that gets included in that implement concrete examples of that abstract class or module.
Right.
And they have
and
they have all the methods and all that stuff. Yeah. And it's like an abstraction of the lower level.
Yeah. Okay. That makes sense now. So the next section is kind of talking about decoupling classes. So she does mention to try not to use super and inheritors. And then she suggests using hook methods, which I am also still fuzzy on.
Yeah, that was what she went over a lot in chapter 6, where it had, it didn't actually explicitly call super. What it did was it I have to go back and look at it, but
Yeah, I wasn't clear on
I
that.
don't want to say wrong here.
Yeah. So I think it might start on 134. Is that page
Yes.
134?
Yes. Where she actually, it's really, she shows it off in,
Oh, the post initialize, is that what that is?
yeah, where she actually shows it off in page 136 and 137 inside a bicycle, where it does post initialize args, and then post initialize actually gets defined in the lower level. But the actual, so she uses hook methods. So every class that gets initialized has an initialize method. And you don't actually define the initialize method on the subclass. You define it on the superclass, and then the superclass uses hooks to reach down into the subclass to get the information that it needs.
Okay, that's right. Yeah, that I remember that now. So the subclasses don't have initialize methods at all.
Right.
They just have the post initialize methods, and
they
then
have localized animation method or the spares method or whatever needs, and then the spares method reaches down into the subclass. So like if you call spares, it doesn't exist in the subclass. It only exists in the superclass. But the superclass is down into the class and gets the local spares and combines that with the default spares.
Mm-hmm.
And the superclass initialize method reaches down into the subclass and gets the information it needs to build the initialize method properly.
Right. Okay, yeah. So instead of sending super up, we're asking for stuff down.
Right. And it's super obvious that that's what's happening because none of your classes are going to have, for example, an initialize method. And when your class doesn't have an initialize method, that means it has to be using hooks.
Right.
So it becomes really obvious, really quick what needs to be defined and what doesn't.
Right. Right. So here she talks about using these hook methods to decouple classes.
Right.
Let's see. So, okay, so she says, instead use hook messages to allow subclasses to participate while absolving them of responsibility for knowing the abstract algorithm. So I guess it's just keeping the subclasses as minimal as possible. Is that a correct?
Yeah. Well, and keeping them only putting in them the stuff that's unique to them. I think. Let me see. What page is that on that you're reading that from?
161. It's like the first sentence after the semicolon. It's under preemptively decouple classes.
Okay. Yeah, and use hook messages to allow subclasses to participate while absolving them of responsibility for knowing the algorithm. Yeah. So okay. So the template method is the thing that implements the algorithm, and the subclasses, they don't need to know the algorithm because of the fact that you're using hooks.
Right.
They just need to know what stuff they need to send back when the hooks reach into them. But they don't need to know the entire. They don't need to know the entire algorithm. That only gets implemented inside of the abstract template.
Okay. So in this case, that's the super, or the Yeah,
it's always going to be the super.
Right.
Or the module
Right. Okay.
Which I don't know how that would work. I don't know how that would work with a module because I don't think you can define initialize in a module.
Right. Yeah, I don't think you do.
Sure how that works. You could still do hook methods. You just couldn't do that hook method.
Right.
You know what I mean? Like you could still have like local spares and define spares in the module and reach in to get local spares. But you couldn't, I don't think you could do post initialize because I don't think you can define an initialize. Maybe you can. I never thought of it. You can't, because I know you can't actually initialize a module.
Right. Well, I think so. It looks like in the examples that she gives, she doesn't have initialize methods in these modules. But she,
Yeah. I think that would make sense because so the example that she gives of like mountain bike and stuff like that, bicycle is actually superclass, and then mountain bike is the subclass. So bicycle is going to have an initialize method because it's initializing for the mountain bikes and stuff like that.
Yeah, it looks like it looks like bicycle has the initialize method and the other ones don't.
Yeah. I don't know. You just have to take it case by case.
Yeah.
I wonder how that would work. I wonder if you could even do that. If you could define the initialize and have a hook in a module like that. Like I mean, it makes sense that you could have a normal hook. But I don't know if the initialize. I wonder if Ruby would throw an error and be like, yeah, you don't have initializers in your modules. Or I wonder if it would let you do it.
I don't know. I wonder if it's.
I have to play around with that this weekend.
Yeah. Homework.
Yeah, I'll try to remember to do that, and I'll come back next week with an answer.
Cool. Yeah. So yeah, that would be awesome because.
Let me write myself a note to do that.
So she also kind of says, let's see, hook methods solve the problem of sending super, but unfortunately only for adjacent levels of the hierarchy. So let's see. So I don't really know what she means by that, honestly. Hook methods solve the
I
problem
was
of
writing
sending super.
myself a note. What was it? Let me get Craig's here.
The second paragraph on page 161, hook methods solve the problem of sending super, but unfortunately only for adjacent levels of the hierarchy.
Okay. You can only call up and down like one level. You can't. You don't. It doesn't work for like. For example, bicycle sent hook local spares that mountain bike overrode. This hook method serves its purpose admirably. The original problem reoccurs with monster mountain bike or the example she gave at the beginning, which was like recumbent mountain bike. Like, that's still not the hook method doesn't solve that problem.
Right.
Which I think will be something she tries to deal with in the next chapter probably.
Yeah. Yeah, because I don't think we resolve it here. But so I just tried to look up something on online the answer to that question. And
She says here, in order to combine its own spare parts with those of its parent, monster mountain bike would be forced to override local spares. So you would have to define it locally in the actual monster mountain bike instead of in bike. And then it would have to call super. So if you call super, calling super, it would call it would have to you could make it work, but you would have to call super to do it. She doesn't like calling super.
Gotcha. Yeah. Okay. Yeah. Cool. So yeah, I just tried to look about Stack Overflow, and it looks like I'm getting an error. So
What are you looking at?
Whether modules have initialized methods. Anyway, so
I know they don't normally. I wonder if you can define initialize in a module. I help if I spelled initialize. I need to see. Is it possible? Oh, yeah, Stack Overflow is currently down.
Yeah, yeah. I just got some
Wow.
funky looking
That
errors
is
on my phone.
rare. Okay, we'll have to.
Yeah.
I find out for myself anyway. We shouldn't be looking it up.
Right, right. Yeah, and yeah, that's kind of funny because it's like, oh no, Stack Overflow's down. I'll never know anything.
Stack Overflow is karmically slapping our hand for not trying it for ourselves.
Right. It's like, nope, just figure it out yourself. Like, dang it. Fine. So okay, so the next, so kind of to remedy the issues that she was talking about with the hierarchies, like getting ridiculous. She kind of classifies them into 4 different shapes, I guess. Shallow and
From
narrow,
less bad to
right, less bad to, yeah. So shallow and narrow, which is easy to understand. Shallow and wide, which is like a bit more complicated. Deep and narrow, more challenging, and they also tend to become deep and wide, which is difficult, costly, and she warns that you should avoid.
yeah, because that also tends to get super dependent on one another. Like things if you refactor one, it tends to break a whole bunch of stuff.
Right, they're tightly coupled.
Yeah.
That's not good. So I think, yeah, so that's actually the end of the chapter. Cool. So here's the summary again, which is Ruby modules are used in between objects that share a common role and need to share behavior. So great. Any like last thoughts, questions? Jay, did that totally go, like, did that not even make sense, or did it kind of vaguely make sense?
I think we lost Jay.
Okay.
I think he was having issues. He dropped in and dropped out for a little bit.
Gotcha. Yeah, I can't see anything except for the PowerPoint, so.
Yeah, we lost Jay.
Okay. Well, he can comment later and tell us what he thought. So, yeah. Do you have any final thoughts? I'll go ahead and just stop sharing.
I learned a lot from this chapter.
Yeah, same.
It's not something that I've done. I've done some inheritance with classical, but the module inheritance was very new for me.
Yeah, I guess I'd seen it like in the context of gems before, but I never really understood what that meant.
Right. Well, and with gems, you're ideally never having to actually go in and look at the module.
Right.
You don't want to, or something's going wrong.
Right. So I guess, do gems kind of act like modules then, or are they modules? I don't
know how that works exactly. I think that gems are their own thing.
Right.
But I think they can define, like gems are clearly their own thing because they have like a separate directory and stuff, and they get loaded up. But I think that they can define modules and classes for you. Like I know some of them can. For example, like the devise gem defines user and a bunch of other stuff for you. And they can also give you modules, I think, that you can include.
Right. Yeah, because I guess I'm just thinking in terms of like SAS and the mix-ins with that, and how some of the frameworks will they'll give you like a bunch of mix-ins that you can use.
Yeah, I think that you can get gems in Ruby that do that, but I don't think that that's strictly like something that like gems are kind of their own thing.
Right.
I know. Okay, so I think a lot of Ruby's standard library acts kind of like modules, except they're like automatically included, or maybe they're not. You have to require them. So instead of like including a module, you require it at the top. Well, the same thing with stuff from the standard library. So like you can require time, but then you have to call an instance of time. So I don't know how that works. Yeah, modules are their own thing.
Yeah. Yeah, I guess because they seem so. I mean, obviously they're similar to classical inheritance, but they're not obviously not the same. But
they're really super useful for namespacing. I know that. Like she doesn't talk about it in here, but that is one of their more obvious uses that actually tends to prevent problems and not create new ones.
Yeah,
Because they let you basically reuse the same class name multiple times in your app without breaking things.
which is helpful. Yeah. So are you working on anything cool or new?
I helped one of the Code Newbies people this weekend with he had to build a little real quick app for a job application that he was doing. And I sat down and he had like the basic like bare bones Rails started and the gems we knew we were going to need installed. And then we actually sat down together and built the app this weekend.
Cool.
Got it working.
Neat.
Yeah, it was pretty cool.
That's awesome.
What about you? Have you been doing anything cool?
No, I'm still working on just like my website, which doesn't have any Ruby with it yet. So I'm just, I like need to get that done. It's just like taken so long. I don't know why it's taking so long to do, but so it goes. I
got to play around with a gem called Time Zone. While we were doing that, you give it so like what we were doing was we were giving it coordinates, like geo coordinates that we were getting from the GeoKit gem, which is something I'd used before. And you give it those coordinates at a specific time, which in this case was just time.now, and it tells you, it returns like a, I think it was an object. And it tells you like what time it is in that place, and you can tell whether or not that it's daylight savings time at that place currently, and you can tell like it's just different, like it's time related stuff. It was cool. I hadn't played around with a gem that could track things like daylight savings time and stuff like that before.
Yeah, that's neat.
But
I think
we got it working.
Cool. I think I've actually seen that before or come across it somewhere because it sounds familiar. It might have been. I think when I was first learning, we had to build like a weather app. I think that was part of it because you had to see if
that would make sense that you would need like time and like location stuff associated with it.
Yeah, or maybe what was it? Oh, you know what I did? You know what that was? I had to include it or require it in, I want to say it was the first Ruby Monday blog. Something was breaking without me using it. And I don't know where I found to use that, but.
Yeah, what he had to do was you had a form that you entered with a country and a region in that country, and it would get the coordinates for the region, and it would save the actual country and region that you listed to the database, and then it would get the coordinates and save those to the database, and then when you actually went to the index, it would have a list of all of the ones that had been entered, and it would look up the time currently at that place and tell you whether or not it was currently daylight savings time there.
Cool.
And display
well,
that
it's about to be daylight savings time in like 2 days, so
right.
It's in action. That's neat. Oh man. Well, we finished like 30 minutes early, which never happens. So that's kind of cool. What?
We burned through this chapter.
Yeah, and I think also because we have less people, which always makes it faster, but it's also we were just kind of building off of classical inheritance.
Yeah, it was very similar to 6.
Yeah. So let's see. I'm trying to think about the next couple weeks.
Well, let's go ahead and end the recording.
Yeah. Okay. Bye, everybody.
Bye.